I will be going to discuss is the distillation of crude oil and the uses of some important fractions of the distillate. The key step in the refining of crude oil is distillation. Distillation, it is also called fractionation, and it is the separation of components in the crude oil into groups of hydrocarbon compounds having different boiling point ranges. This process is carried out in a distillation tower at atmosphere pressure and then followed under vacuum. The groups of hydrocarbons separated are called fractions or called cuts. CUTS. Low boiling fractions vaporize at atmosphere pressure up to a temperature below 400 degree centigrade without the cracking or breakdown of the hydrocarbon compounds. High boiling fractions are vaporized under vacuum at a temperature much lower than 400 degrees centigrade and cracking is avoided. Thus, all the low and high boiling fractions of crude oil are separated by atmospheric distillation followed by vacuum distillation without cracking or degradation of the original hydrocarbons present in the crude oil. First of all, after the removal of oil fractions, the vacuum residue left requires a solvent extraction, and this solvent extraction of residue is called desulfating, and this recover the remaining valuable petroleum fractions in the residue. Atmospheric distillates are the major source of petroleum fuels, and the vacuum distillates are the sources of fuels, wax, lubricating oil, base stocks, bitumen, petroleum, cokes, etc. Mainly by secondary treatment like extraction, thermal or catalytic treatment result in these fractions. The separation of hydrocarbons can be improved if the vapor and its condensates, it is called a reflux, are in intimate contact for some time during the distillation. And this result in a reproducible distillation analysis. And this method of distillation is known as true boiling point distillation or TBP distillation. A routine crude distillation test is carried out in a standard TBP distillation apparatus in a packed column of specific size and packing materials with a certain amount of reflux ratio, that is reflux by vapor ratio. And this figure shows the TBP apparatus, and the distillation is carried out in this apparatus, and it consists of a long column, is a packed column, and the distillation flask is below this column, and the distillation flask is heated by electricity, and the temperature is noted by a thermometer, and the vapors are condensed through a condenser, and then vacuum atmospheric connections. After that, the separated fractions are collected in a graduated cylinder. In a refinery, the distillation is usually used to separate the different cuts or fractions in large rates continuously. Here, the yields of the raw cuts are slightly different from that of TBP analysis. In fact, a distillation column is designed on the basis of TBP analysis of the crude oil. Crude oil having wide difference in TBP analysis cannot be distilled in the same column without sacrificing the yield and quality of the product. It is therefore inevitable that the design of a distillation column of a refinery must be done judiciously depending on the availability of the crude oils, which may have little differences in the TBP analysis. Now we are going to the atmospheric distillation of crude oil. Crude oil from the desalter. That is, desalting is the process of removing the contaminants like water, salt, clay and sand in the crude oil. And the crude oil from the desalter is heated in a train of heat exchangers up to a temperature of 250 degree to 260 degree, and then further by tube still heater. It is also known as pipe still furnace to a temperature of 350 degree to 360 degree. Then after this we get a hot crude, and this hot crude is then flashed into a distillation column, which is a tall multi-plated cylindrical vessel that separate the petroleum fractions or crude oil fractions according to the difference in their volatility. And this figure shows a simple schematic representation of a distillation tower. Top of the distillation tower pressure is maintained at 1.2 to 1.5 atmosphere, such that the distillation operation can be carried out at a pressure close to the atmospheric pressure, and for this reason this column is also known as atmospheric distillation column. Vapors from the top of the column consist of hydrocarbonic gases, naphtha, and these emerges at a temperature range of 120 degree to 130 degrees centigrade. The vapor stream associated with the steam used in the column bottom and the side strippers are connected by water cooler, and the liquid is then collected in a vessel situated at the top of the column. The part of this overhead liquid, that is oil phase only, is returned to the top plate of the column as the overhead reflects, and the rest of the liquid is drawn and sent to the stabilizer column, which separates gases from the liquid naphtha. A few plates below the top plate, the kerosene fraction, which is drawn, and it draw at a temperature of 190 degree centigrade to 200 degree centigrade. A part of this fraction is returned to the column after it is cooled by a heat exchanger. This cooled returned stream is known as circulating reflux, and it is essential to control the heat load in the column. The rest of the draw is passed through the side stripper, where the steam is used to strip out the undesirable boiling fractions to maintain the desirable flash point of kerosene fraction, which is then further cooled and sent to the storage tank as raw kerosene. And this is also known as straight run kerosene, and this straight run kerosene boils in the range of 140 degrees centigrade to 270 degrees centigrade. And a few plates below this kerosene draw plate, we can see the diesel fraction, also known as atmospheric gas oil or straight run gas oil or straight run diesel, and this is drawn, that is the diesel fraction is drawn at a temperature of 280 degrees centigrade to 300 degrees centigrade. After cooling, part of this is returned to the column as circulating reflux, and the rest is steam that is stripped through the side stripper like kerosene to adjust the flash point. This diesel fraction with the boiling range of 270 degrees centigrade to 340 degrees centigrade from the stripper is then cooled and sent to the storage tankers. In some refineries, jute batching oil, it is called JBO, which is an intermediate cut between the diesel and the bottom residue, and this is also drawn at the draw temperature in the range of 300 to 330 degrees centigrade, followed by stream stripping. The residual oil drawn from the bottom of the column is known as a reduced crude oil, it is RCO, topped crude or long residue. The temperature of the steam at the bottom reaches around 340 degree to 350 degree, well below the cracking temperature of the oil. The reduced crude oil RCO is brown to deep chocolate colored stream containing high boiling fractions that cannot be vaporized at the prevailing temperature and at atmospheric temperature of the column without cracking. Since the depression of boiling point occurs as the system pressure is reduced, boiling fractions remaining in the atmospheric residue are therefore distilled under vacuum in a separate column, and this is known as vacuum distillation column, where high boiling fractions are separated and collected as vacuum distillates. A typical atmospheric distillation column contains around 41 plates, where the hot feed crude oil is flashed in the fifth plate, producing the top distillate. Here we get IBB at 140 degrees centigrade cut, straight run kerosene in between the temperature 140 to 270 degree cut, straight run diesel, we get the straight run diesel cut in between the temperature 270 to 340 degrees centigrade, and JBO oil we get JBO cut in between the temperature 340 to 360 degree centigrade, and the bottom residue, that is RCO, that is obtained at 360 degrees centigrade, and these are shown in this figure, and this figure shows a typical crude distillation unit. And the top product goes to the gas and naphtha separation plant directly from the column. Kerosene, diesel and JBO from the separate strippers sent to the fixed roof storage tankers. By introducing the liquid from the 7th plate back to the 5th plate, 4 to 5% of the feed is overflashed. The overflash helps in further removal of the heavier component carried over with the lighter stream. Part of the RCO cut from the bottom of the column goes to the vacuum distillation unit, and the rest goes to the steam heated fixed roof storage tank, where the components are stored. The pipeline carrying the RCO to vacuum distillation unit is well insulated and steam traced to avoid congealing of the product in the line. A temperature between 180 degree centigrade and 200 degrees centigrade in the transfer line is usually maintained. And now I am going to the composition and uses of some important fractions of the distillates of crude oil. 5 broad categories of the products are obtained by the distillation of crude oil. Their primary use are shown in this table, and first the 5 broad categories include gases, gasoline, diesel fuel, jet fuel, kerosene or fuel oils. These gases are mainly used in industrial and residential fuel, and the gasoline is used as a fuel in the spark ignition engines, and diesel fuel, and it is used as a fuel in the compression ignition engines, and jet fuel or kerosene is a fuel in the jet engines and gas turbines, and finally the fuel oils, they are used in the industrial or residential uses as fuels. The first portion, that is first broad category, gases are mainly consist of propane, butane, and they are in the dissolved state. They can be liquefied and sold as useful fuel as liquefied petroleum gases. And the gasoline produced by the distillation of crude oil is called straight run gasoline. The mixture boils in the range 25 to 150 degrees centigrade. The major chemical component of straight run gasoline are straight chain paraffins in the range of pentane to nonane. Kerosene consists of mainly compounds with 10 to 12 carbon atoms with that boiling in the range of 170 to 300 degrees centigrade. Fuel oil boils at the temperature above 300 degrees centigrade and consists of molecules with 12 or more carbon atoms. The residue is the material that does not boil at this temperature under distillation operation. In petroleum businesses, it is often referred to as resid. Special treatment of resid can produce heavy fuel oils, asphalts, waxes, and grease. Gasoline is the most important product of petroleum refinery. A good quality old deep crude oil may yield 20% straight-run gasoline upon distillation. Gasoline components typically have 5 to 9 carbon atoms, while other high bare boiling distillation products have larger molecules. References: Fundamentals of Petroleum and Petrochemical Engineering, Uttam Ray Chowdhury, CRC Press, Taylor Francis Group, Stivers Chemical Process Industries, George T. Ashton, Industrial Chemistry, BK Starma.